All right, here we have another physics application, instantaneous velocity. This is a distance time graph. This being distance here, and this being our time graph here. And you can see that the path of whatever object this was, maybe it was something thrown off of the top of a bridge and it's falling down into the water or something like that. This type of curve would be generated for falling objects. And you can see that this isn't straight. This is a almost parabolic looking curve, which suggests that it's accelerating over time. So the slope of the lines that would hit this in one point are called tangent lines, and that would be any, like if I wanted to know, and I kind of pick this point right here, if I wanted to know the speed of that point on that graph, that would be called its instantaneous velocity. So I don't want an average velocity this time. I want to know how fast it's going right there. And what the common mistake people will do is they'll say, I'll use like a purplish line here. Try to do my best. Something like that. And they'll say, oh, well, this is maybe about 18 right there. Maybe 18. And then that's down to 3. So 18 divided by 3 is 6 meters per second. That is completely wrong. That is not how you do that. If I want to find the slope of, say, this, I need a green line. We'll make it a green line. And I want it to go, say, right like that. Okay? And we'll say that that green line hits right there. Okay, that's tangent right at that point. What I would have to do is use the slope formula, right? Back to algebra 2, or algebra 1 even. The slope equals rise over run, which is y2 minus y1 over x2 minus x1. So what we need to do is find 2 points. I got one right here, and I have one, probably my next best one would be like right here, because that's over this mark here. So this, if this was in fact 18, this would be point 318, and this would be point, say, 2, and then we need another little reference line going across here. I think it's about 6, something like that. About 2.6. Switch everything around there. And if we plug this in, we're going to get our slope. So this would just be 18 minus 6 over 3 minus 2, which is 18 minus 6 is 12. 3 minus 2 is 1. So we would get about 12 meters per second. Our velocity would be about 12 meters per second at that point right there. If you wanted to know what it was, say, here, I invite you to try to figure that out. But you would need another reference point, and then you would just draw another line. And if I drew, very difficult here, another tangent line, say like that, you could see that the slope of that green line is much faster than, say, the slope of a point traveling, or a line tangent to that. Let me draw another little picture of that. So like right there, the slope of this line is much slower. So the speed, the whole point of this, the instantaneous velocity is the slope of the tangent line to the graph. And a tangent line hits the graph one time. One time. That's the basic idea, and there's how to find the instantaneous velocity of a graph. You do have to just read the graph and figure the slope out. Talk to you later.